Hey everyone, welcome back. Today we are wiring up the VFD and hopefully if time allows we'll get to see the motor working for the first time today as well. So in regards to the VFD, VFD is a variable frequency drive. They are required, not specifically required, but and we'll talk about this in a bit, but they're required to run a three-phase motor on a residential circuit. So most residences use single phase power, so you need something to convert from single phase to three phase. In looking around and doing my research, you could just get a straight phase converter, but the cost difference between that and a variable frequency drive is minimal. So I decided to go with the variable frequency drive, which gives the ability to modify the speed as well. So my motor is a Tech-Top 2 horsepower three-phase motor. For a 2 horsepower motor, I needed a VFD capable of 2 horsepower. Everything I read pointed me towards the KBAC series. The KBAC-24 will go up to 1.5 horsepower. The KBAC-27 goes up to 2 horsepower, and the KBAC-29 is good up through 3 horsepower. The KBAC-27 comes in at around $360, which is fairly expensive. But from what I read, the other options, which come in between $100 and $150 or a little bit more, are significantly more difficult to wire, and they don't come in a totally enclosed enclosure. So you have to also build an enclosure for it, and it just wasn't worth the headache. So what we're looking at here is the KBAC-27D. It comes, I didn't buy any accessories. It comes sort of just like this. There are additional accessories for a forward reverse stop switch, an auto or manual start switch, and a main power off switch. I will probably end up getting some sort of emergency power off switch to wire into this as well, but I don't have it quite yet, and it's not required to use the system. So when we open it up, I know it looks a little confusing, but this is actually a really simple setup. You're going to notice 5 pins down here, and these 5 pins are for your input line, which takes in either 110 or 220 volt into your input, and then your output, which is 3-wire going to your motor. Now, when I say either 110 or 220, for the the KBAC-27, it's capable of a max horsepower of 1.5 on 110 volt, and it's capable of a max horsepower of 2 on 220 volt. So I've got a 20 amp 220 volt circuit already run out to my garage, so we're going to be running a similar gauge wire up to this system. The other thing that the KBAC comes with that's really helpful are additional rubber plugs, depending on how you want to set it up. So at the bottom it has 3 holes. It has 2 1/2-inch holes and 1 3/4-inch hole. As you'll see, I already have the plug in one of the 1/2-inch holes, and then I have one of these strain relief cord connectors. They have rubber grommets that seal around the cord that will basically help keep all dust out. And then we have an additional 3/4-inch, same thing, strain relief connector. As you can see, it has a rubber grommet inside that will tighten down over the wire that we have. Now, a mistake I made was that when I originally went and bought the wire and I got it all laid out, I bought solid core copper wire, a typical yellow coated Romex that you have for most housework. And that was... When I was doing some research, I found out that you should use stranded core wire. Additionally, when I was manipulating it before attempting to install it yesterday, it was really difficult to try to make these tight turns to get into these areas in the box. The wire I ended up getting is the same gauge. It's still a 12 gauge wire. And what you'll see is the smaller stuff here on the left is 12-3 wire, which means it has 3 total wires in it, which for our use will be ground and 2 hot. And then I bought a short bit of 12-4 wire, which will run the 3 lines from the the VFD to the motor, as well as ground for the motor as well. You'll see the VFD also has these 4 grounding pins for what you need. All right, so I didn't have a 1/2-inch retaining ring for this strain connector, so I just kind of slipped it in the other direction, and then I'll use the compression nut on the back to kind of tighten everything up. And then I did have a 3/4 inch retaining ring lying around from something else, and so we'll slide that in, and we'll just quickly hand tighten it and grab a pair of pliers. And just tighten it down. All right, so the first thing we're going to do is grab our 12-3 wire and run it through that connector. Because it's a insulated connector, it's a kind of a tight fit, and so I'm not going to be stripping any of the wires until we get them inside. So once we get it through, you can pull through a little bit extra, get that wire nut on the outside just to keep that whole thing from moving a little bit. So we'll pull through more than we need.
All right, so what you're going to see over the next 3 minutes is the process I had to go through to wire this up. It took me almost an hour to do it because I didn't have the correct ends and was just kind of using what I had lying around. Do yourself a favor, spend a little bit of money, buy the correct ends, and this will go a lot smoother than it did for me. Hopefully this music is more interesting than the amount of time spent wiring these things. So the picture you see here is the final wiring that was used. I ended up doing black to U, white to V, and red to W, which for me ended up with a counterclockwise rotation, which was correct for my motor orientation.
All right, here we're outside in the garage. Just getting ready to do the final wiring on the KBAC-27D. Go ahead and turn that around. All right, that cord is ready. We'll put that on the ground. This is the wire that runs to the motor. As you can see, my motor is a Tech Top 2 horsepower, 3-phase motor. Runs at a little over 3,500 RPMs. I've already popped the cover off, and now I'm gonna pop the hole down there out. I am using, as I said earlier, I'm using one of those compression rubber fittings for this. So this actually screws directly into here and doesn't need a retaining ring like we needed inside of the KBAC. So we're just going to go ahead and screw that on right now. Hopefully this doesn't come back to bite me. Alright, should be good there. Alright, so your motor should have a wiring diagram. Typically, if you don't have the booklet for it, it's going to be on the nameplate on the top. Sorry, it's on the connection plate on top of here. I knew it was close. So what this says is that I have a low voltage and a high voltage difference for wiring. And I don't know if I can get you in there to see that. But what that means for 2 horsepower motor, for this 2 horsepower motor, is designed to work on either 220 volt or 230 volt or 460 volt. So in this case, 220 volt is considered low voltage. So what this is telling me is it has lines T4, 5, and 6 connected together, lines T1 and T7 connected together, T2 and T8, and T3 and T9 are all connected together. This motor, when I bought it, it was used, so it's actually already done that for us. And so what we're going to do is the 3 pairs, the T1 and 7, T2 and 8, and T3 and 9, all correspond to the U, the V, and the W inside of the motor. So those 3 will get connected directly to our 3 lines coming in here. Additionally, if we look inside, up here at the top, there's the grounding pin. So the grounding line that comes in will connect to that. And then the other 3 that are connected together just get wire nutted together, and that's how they go. All right, so what we're gonna do initially is we're gonna shove this wire up through our wire nut, our rubber washer, since we know that's a stiff fit.
Again, this wiring takes a lot longer than it should, so I'm going to go ahead and speed up this video, turn on some music, and let it go. The key points on this are to strip more of that casing back than you should. Also, be careful when you're doing this, because as I did it, I cut through the interior wire and caused some problems for myself along that front. But again, enjoy the music, and we'll pick it up at the end.
On righty-tighty, and so when you're twisting your wires together, you want to make sure they're twisted to the right. All right, so the next one is going to be our first pair, which is going to be 1 and 7, sorry. 1 and 7 is going to hook up to our U line, which is black. So this is my 1 and 7. I'm going to grab our black one in there. And just like when we twist the wires together, we're going to twist those up to the right. Yeah, that's not going to work. I'm going to have to cut back that insulation farther to give me more freedom with those wires. That should allow me to pull out some of the extra. Alright, so I just slit down the casing. That gave me a little more room. Alright, I said 1 and 7. 1 and 7 is my U. So we're going to go ahead and wrap the 1 and 7 collection around my black. And then twist that onto my wire nut. That's one. The next setup is 2 and 8 goes to V. So this is my 2 and 8. V is red. And then our last one is going to be 9 and 3. And it will be corresponding to our white line. Alright, that should be everything. Alright, so I'm just going to put this back down so it's sitting, and before I close everything up, so you can take a quick look at my connections, make sure nothing's touching. Alright, so this is going to be the first motor test. So I just want to give a quick up close of the wiring that we did. Alright, here goes nothing. Let's go plug it in. So what we get on the VFD is status light is orange, power is green. I'm going to flip the switch from the stop position up to the start position. The orange status light turns to a green flashing status light. My frequency is still at 0. So now we turn this on. Ooh, and it works. So over at the motor, I've got it going really slow, but if you can tell, it's actually going backwards from what I want it to do. So what this means is that we need to switch 2 of our lines. So I'm going to go ahead and put this back on the tripod, and then we'll get those lines switched and we'll do another test. Alright, to get this going the other direction, we need to reverse the red and the white wires. Either how they're hooked up in the motor or how they're hooked up in the VFD. I'm going to do it in the VFD just because it seems a little cleaner than undoing those wire nuts. Those waterproof or indoor outdoor wire nuts have like a liquid in them that melds everything together. Alright, so first thing to do is unplug power. Status light is still on. It'll take it a second to go off. We can open it up in the meantime. I didn't fully close it. I just closed a couple of them. Alright. right, let me give you a little better look at this while I'm doing it. So what we're looking at here is that the wires here need to be reversed. I'm just going to swap the position of the red and the white. Shouldn't be too hard. Now the red's in there. I'm just going to quick close it back up. Now I'll let you see the wheel as much as possible as we give this a go in the other direction. All right, so plug it back in. Status light comes back on. Frequency still at 0. Click start. Status light starts flashing. And there we go. Motor's going the right direction. Great. Everything works great. All right. Final steps are going to be finish closing this up. I'm just going to tilt it up. Put all of my fancy wires back inside. And then I'll put the faceplate back on. Probably shouldn't be poking around in there without turning all the power off, but everything should be good. Last step is going to be tightening down this nut, which will keep all of the dust and debris out as it compresses that nut over the wire. All right, great. Tip it back up. Put it back up. I'm gonna just make sure we didn't cross any. Still looking great. All right, success for the day. Got the motor wired up. Hey everyone, and thanks for watching as we wired our KBAC-27D. This was one step in the process of building a 2x72 grinder. Hopefully that video will be out next week. If you're interested in seeing that as well, I did a No Weld 2x72 grinder. Please hit subscribe below and you'll be notified as soon as that comes out. Again, thanks for joining us, and I hope you'll come along.